Hello and welcome back to Mikey's Flightdeck. Today with the building of the first officer's upper MIP panel. I start with installing a small momentary on-off-on switch and two 8-position rotary switches. To fix the 3 panel layers, I used 15mm hex standoffs and some screws. Two orange annunciators are needed. Also 3 push buttons with LEDs. You can watch the making in my last video. One of the most challenging parts of this panel is this 3-colored gauge here. I thought a lot if I can paint it somehow, or if I can make engravings or inlays of different colors. And at the end, I decided to come out with a solution that is a combination of all of these sorts. Here I have the drawing that came out of my 3D model. You can see here the plate with a cutout, and this will be made from white acrylic that is cut out and then spray painted black. And I will make a cutout also from white acrylic. This will be done in the different direction. So when you have seen the multicolored panels of my overhead panel, there I describe this method in detail. I will flip over this panel piece here before cutting it out. So all the cutting will be done with the backside up. And this cutout here will be done in the normal direction. And though the 2 parts slide together very tight, and there will be nearly no gaps where light can come through. And when we look closely to this piece here, then you can see these green lines here. These are lines so that the laser can make a marking on that piece. Really with a small amount of power. So not a deep engraving, just a really thin and fine marking. And this marking will be needed to place a masking tape. So I can see where the masking tape has to be. I will mask out everything that shouldn't be painted in the first step. Then I will airbrush, for example, all the red sections. Then I will place a different masking tape on other locations and paint the piece here yellow and then green. And so I will come out with 3 areas of different colors. And after the painting, I will place this piece back here into this acrylic piece, place it onto the laser, and then make all the engraving at once. And because these markings here are at the same place like this big black engraving here, you will not see this at the end, so it will disappear. So let's see if this will come out right. The needle should be driven by an X27 stepper motor. I have now glued the 3D printed coupler to the shaft of the stepper motor and the shaft to the needle head here. And now I will align the stepper motor to one of its 0 positions. So I turn the coupler manual and you will feel when the end is reached. So now it is at one of its limits. And then I will stick in the needle here and into the coupler hole and align the needle to the 0 position and then glue it into the coupler. During the configuration tests of this panel, I realized that I had massive problems fixing the shaft of the needle to the small shaft here of the stepper motor. I tried to glue it, but the shaft is very thin and so there is not much surface for the glue to hold on, and it came loose after some rotations of the stepper. And so I decided to change these X27 steppers to these 28 BYJ steppers. These are a little bit bigger and heavier, and they don't have an internal end stop, but they have a much bigger shaft, and the shaft is even flat on the sides, and so it will be much easier to stick a coupler on it that won't move anywhere. So I made a redesign of the gauge and now installing the different stepper. Replacing this stepper motor isn't as easy as I thought, because this is an endless turning stepper motor now. So that means that there is no internal stop of the motor and the motor doesn't know its exact position. You need some sort of electrical signal that tells the motor when it has reached a certain position. Most people are using some little micro switches for this purpose. There is some sort of finger mounted to the shaft of the motor which presses the micro switch every round, and so the motor knows that it has reached this position. When I think at the chrono that I will build in a later episode and the needle is running and this switch is pressed very often, I think there can be a little bit of wear off, maybe. And I thought if there could be some other components that could replace this micro switch. And I found a really tiny component called H22A3. It is an optical sensor and it works like following. There is a small LED in the upper segment and it is emitting light down to some kind of receiver. And when something comes in between this light beam then this is registered by this component. So I think I will add some kind of finger to the 3D printed coupler, and this finger will slide in the slide beam, and then I have my position signal. It's a little bit more work than installing a switch, so we will need some more resistors and 5-volt power supply for this. But I will come to these electrical details in the corresponding configuration video. In this video, we will now just concentrate on building this thing.
The stepper motor comes with an interface card, which I glued to the backside of the backlighting panel.
And here it is at its final place. The construction of this brake pressure gauge took way more time than I expected, because beside of this, the panel is absolutely identical to build like the captain side version. And if you want to see how I'm testing this thing, then watch my configuration video where I go through all my configuration steps here, very detailed, and testing this whole unit at the end. Spoiler alert, it's working. You will find a complete set of files to cut out and engrave your own panel segment at home, as well as the 3D files for printing these buttons, knobs and annunciators here, as well as the Gerber files for the shift register PCB. Everything can be downloaded from the member section of my website. I will continue my way to the remaining holes here in the MIP panel. And if you don't want to miss this upcoming episode, then subscribe to my channel to stay informed about any upcoming new video from me. And I hope we'll see you soon back on the flight deck. Don't stop building,